Okay, so for the first one up here, obviously we're working inside the parentheses, but then we're working inside the second set of parentheses here. I'm just going to rewrite the problem so I can cheat here. What do we have to do first? 8 times 3, which gives us 24. Then, of course, we got the 27 minus 24, which is 3, and we're down to a single number, so I can get rid of the parentheses. Got to remember, come on, put in multiplication. Now I'm moving on to this set of parentheses over here. 9 minus 4, which is 5. Down to a single number, so I can get rid of the parentheses. Do I have to put in multiplication? No, there's already an operation on each side of the parentheses there. Back up to the bigger set of parentheses. So what do we have to do next? 2 to the third, which is 8. And then 2 times 3 is 6. And that's all multiplication division, so it's addition and subtraction. 19 minus 6 is 13. 13 plus 5, 18. And minus 8 is 10. So again, I can take out the parentheses and put in multiplication. 3 times 10 is 30. So 9 plus 30 is 39, plus 1 is 40. Missed it by a bit?
Yeah.
Cool.
I got the multiplication mixed up. I carried first.
So this next one, we've got to do everything on top first. Then we got to do everything on bottom. So on top, what do we have to do first? 2 squared. So that's going to be 3 times 4. Then, of course, 3 times 4 is 12, right? And then 6 squared is 36. And then 5 times 9 is 45. 36 divided by 12 is 3. So that is 48. On bottom, 8 squared is 64. So yes, minus 1 is 63. Don't need the parentheses anymore. So 63 divided by 9 is 7. 9 plus 7, 16. 48 divided by 16 is 3. What do you think? Good.
What's it called when the numerator is higher than the denominator? It's like a
Improper fraction.
Yeah. When it's multiple like that, it comes down to an even number. Is there a different name for that?
Okay, so for our new stuff for today, we're going to be looking at areas and simple areas of rectangles, pretty much. For a rectangle, the area is defined from, well, all geometric figures are defined from the most basic shape in geometry, and that is a point. A point is nothing more than a location. It has no measurable dimensions. A dimension actually is defined to be a measurable direction. It has no dimensions at all. You take that point and you pull it in a single direction, you create a length. And of course that length is equal to the distance that you moved it. Now that's called a line segment, but we're not going to get into the terminology quite yet. We'll study geometry later on in the course. But now if I take that length, that line segment, and I move that in a direction, it's called perpendicular to the original direction. That means at a right angle. I create a rectangle, but more specifically, for now, we create an area. And the size of that area is equal to that original length times whatever distance it was moved sideways. So another distance. That distance is most often referred to as a width. So those two dimensions combine to make an area. So I'm going to assume all the figures I draw are rectangles, that they have right angled corners, unless I tell you otherwise.
They have that little marking, the square marking.
The little box?
Corner. Yeah,
Yeah.
the box marking.
It's a little square. It means it's a square corner, yes. But I'm not going to bother to put that marking in all my drawings. So to find the area of this, it is the 14 inches times the 6 inches. Now, if you recall, we multiply the counts. 14 times 6, which is 84. But we also multiply the names. Inches times inches, inches squared, or square inches. Now, we're not going to stick with things quite that simple.
Oh, that's easy.
Of course. We're going to look at something like this, where this might be 20 inches by 24 inches, obviously not drawing the scale. And this might be 10 inches and 12 inches here. So now looking at this, there are two ways I can approach this problem. I'm just doing a quick duplicate so it's easier for me to do the second way later. The first way I could do is I could cut it into smaller pieces and add them together. So I could either cut it across here or I could have cut it down here. Either one, it doesn't matter. So I'm going to cut it across here. This piece, I'm going to call that piece 1, is 10 by, what's this dimension? 8 inches. Now I'm going to pause there. This is a skill in recent years a lot of students have struggled with, to find that 8. Any questions on where that 8 came from? 8 is a vertical dimension, so it comes from other vertical dimensions. I have 20 as the whole thing. This piece is going to be the 12, so 12 plus 8 equals 20. So that is, piece 1 is 10 inches by 8 inches, or 80 square inches. Piece 2 down here, that's already 12 by 24 is given, so we don't have to figure anything out there. So 24 inches by 12 inches, 288 inches squared. That adds up to be 368 inches squared for area. Now over here, the other way I could, of course I could have cut it this way too if I'd have wanted to, and it would have been different rectangles, but that's okay. We did it, we picked away. Over here, what I could do is this. I'm just going to make this a big rectangle, 20 by 24, or 24 by 20, however you prefer to look at it, which is 480 inches squared. And I am going to subtract out the missing piece right here. That piece is, well, we already said this is 8 inches here, right? What's this piece? Careful. 24 minus 10. That has to be 14. So 8 by 14, or 14 by 8, however you want to look at it again. That's 80, 112. Subtract that out, we get 368 inches squared. So either way, we come up with the same answer. We better come up with the same answer because the area doesn't change. In a problem like this, it's about the same amount of work either way. It really doesn't matter. But we can run into some of them that might be a lot easier one way or another. For example, this one here. Let's say this is given as 4 millimeters, 20 millimeters, 12 millimeters, and 30 millimeters. We'll give this here as 32 millimeters. This over here is 40 millimeters. And down here, we'll give it as we'll go 36 millimeters. Now to cut this up into pieces would be actually kind of tough. You might cut it like this, I don't know, this and this or whatever. It's going to be weird to cut this up into smaller pieces. Here's one where though, if we make it just a big one, it won't be that bad. We've got to find the overall dimensions. The overall height is just the 40. The overall length, 4 plus 12 plus 30, right? Do you see how we get that? So 46. We've got 4 here, 12 here, 30 here, right? Have to add up. So my total area, 46 millimeters by 40 millimeters, which is what, 184, is that right? Or 1,840, I should say, millimeters squared. Does that look right? $46 times 40. 1840. Good. So that's the total. Now, this piece is easy to subtract out. What size is that? 20 by 12, 12 by 20, however you want to look at it. So that's 240. So now we're down to 1,600. This piece is a little trickier. What's this dimension right here got to be? 8 millimeters. Because this is 40 all the way across. This is 32. The difference is 8. How about this dimension? 10 millimeters. 46 all the way. This is 36 here. The difference is 10. So 8 by 10 or 10 by 8. 80 millimeters. This is subtracting. This is still subtracting. 1,520 millimeters squared. Any questions?
Will we get into millimeter cubed, or is that when, is that
Give me about 10 minutes.
does that get into degree?
Give me about 10 minutes. Well, you wouldn't feel right if you didn't. No, it's just a common structural shape. It's the structural engineer in me. It's yeah, imbalanced. Shoot, I just lost the word for it. This getting old thing really sucks. It's an imbalanced chord I-beam, pretty much. Down here too. In your notes, try to find for me the area of that. So this one is actually about the same amount of work either way, whether you make it bigger and subtract out or if you chop it into pieces. If you chop it into pieces, I'd probably cut it across there. This top piece is 10 by 3. Or 30 millimeters squared. This next piece is 8 millimeters high. How big is it here? 4. 10 minus 3 minus another 3 is 4. So that's 32 millimeters squared. And this, of course, is 8 by, this better be 10 down here still, right? Or 80 millimeters squared, which adds up to 142 millimeters squared. If you had done it the other way, this is, you got to find this overall dimension. So 8 plus 8 plus 3 is 19 millimeters. You'd have 10 by 19. Nope, that's right. 190 millimeters squared. Then you're going to subtract out, this is 3 by 8 here. That's 24. Subtract that out to get 166 and subtract it again, because there's one on the other side. You get 142. That is, by the way, the number one mistake is people mess up trying to find those missing dimensions. It's a skill that with the video society, you don't have to visualize anymore. And in the last 4 or 5 years, it's become a real struggle for a lot of students to find missing dimensions. So if it is something you're having an issue with, please let me know, because I'd be happy to go through more examples of finding those missing dimensions. Volumes. We've always been given the formula that volume is length times width times height, right? But I'm going to give you an alternative one. A volume is an area times a height. So we take that area, that rectangle that has an area, right? So let's say it is 6 inches by 10 inches. So it has an area of 60 inches squared. Well, if I take that area and pull it through space, I've now created a box or a volume. Just like taking that original segment and pulling it to make an area. So the size of that is equal to the area of whatever that original piece was times whatever distance we moved, times whatever height we've given it. So this is, let's say this is 4 inches here. That volume would be the 60 inches squared times the 4 inches of height, or 240 inches cubed. Remember, square inches times inches is inches to the third, or cubic inches. The reason I do it this way is not everything is a box. Obviously, this one here, you could have done length times width, which is just your 60 square inches, times your height. Still, you get 240 inches cubed. But what if it's something like this? Finding the volume of this, now I've got to give you some dimensions yet, obviously. Let's say I tell you that this is 3 inches. This inside here is 10 inches. This inside over here is 12 inches. This is 4 inches. And this height here is 10 inches. Length times width times height doesn't apply here because it's not a box. But I can do the volume as being the area of a base times the height. Now the base on this one is just the bottom, but technically what the base is the shape that can be pulled through the object to make the object. We talked about taking an area and moving it. The base is the area that is moved. Here, this shape, I can pull it up through the whole object. That's what creates that object there. I slide it up, of course it sits on top. It slides through the object. That's what makes that the base, not just because it's on the bottom. So here, the area of that base, I can divide this up. Let's say I'm just going to cut it across here. So this is 3 by, how big is this? 14, good. 10 plus 4. It says 42 inches squared. This piece here is 12 by 4, or 4 by 12, however you want to look at it. Is 48 inches squared. So the area of that base, adding that up, is 90 inches squared. So that my volume is the area of the base, 90 inches squared, times the height of 10 inches. Otherwise known as 900 cubic inches. Now I said the base isn't always the bottom. Great example of that might look like this. So let's give this 12 inches, 2 inches, 8 inches. From here to here, we're going to call that 6 inches, 8 inches. This piece here is going to be 3 inches. Now we're going to call this 16 inches across here. Obviously, the base of this, I've got to give you the width yet. Yes, you're correct. Obviously, the base of this is that piece there. Yeah, this width here is 10 inches. So obviously, the base is that red piece there, because that's the part that I grab on it and slides through, right? So that's what I got to find the area of. So I'm probably just chop it like that. So for the area of my base, I've got this one is 12 by 2. I'm going to leave off the units now just for some speed. This piece here, well, this is 16. This piece is 2. This piece is how much? 6. 2 and 6 makes 8, so this has to be 8, right? Has to be what's left over. How about the height here, this piece? This is 8, this is 3, that's got to be 5. Does that make sense? So that is 8 by 5. Oops, I don't know where the 4 comes from. That is 40 inches squared. This one is 6 by 8 here. So 48 inches squared. That's 112 inches squared is the area of my base. Everybody follow that? I know I went a little fast. So to find my volume, the area of that base, 112 inches squared. Now, I made my height 10 inches on all these just because it makes this next calculation easy. So times the 10 inches, it may not necessarily be a height, it's the distance that the base was moved to create the object. Distance from the base on one side to the base is always on the opposite side as well, to the back side. So it's kind of defined as the distance between bases, is the 10 inches. So this volume is 1,120 inches cubed. Does that make sense? Yeah. Yeah, height, I mean, technically if you tip this over so that the base was on bottom, that is a height. Yeah. But the base doesn't always end up starting out on bottom. In your book, pages 17 through 19, 1 through 39, the odds. These are going to get a little bit trickier, so make sure you try a few more of these at least.
Is this going to be on the unit test?
This will be on the unit test, yeah. There might be a quiz yet before the unit test, too. Might be a quiz before the end of the week. That is a big hint, by the way, for those of you following along at home.